Cell phones are an essential part of modern life, used for communication, information access, and business. However, a potential danger often overlooked is the risk of static electricity. Static electricity is the accumulation of electrical charge on a surface resulting from friction, contact, or induction. When objects with differing charges meet, charge transfer can create a spark. Cell phones can generate static when rubbed against fabrics. This static discharge can occur upon contact with metal, such as doorknobs or light switches. Under certain conditions, this discharge can ignite fires, especially in environments with flammable materials like gasoline or paper. Several incidents highlight this risk. One instance involved an individual using a cell phone while refueling a car. The static electricity ignited gasoline vapors, leading to an explosion. Another case involved a person talking on a cell phone while cooking, where static ignited grease on the stove, causing a fire. To mitigate these risks, consider several precautions. Firstly, avoid using cell phones in areas with flammable substances. Secondly, if phone use is necessary in such areas, ground yourself by touching a metal object. Thirdly, keep cell phones clean and free from dust. Fourthly, avoid charging cell phones on flammable surfaces. Static electricity poses a real threat from cell phones, but by following these preventive measures, the risk of fires can be significantly reduced. Static electricity is a phenomenon where there is an imbalance of electric charges within or on the surface of a material. This imbalance results in an electric field that can attract or repel other objects. Static electricity is often generated when two surfaces are brought into contact and then separated. This process causes electrons to move from one surface to the other, creating a charge imbalance. The triboelectric effect is a type of contact electrification in which certain materials become electrically charged after they are separated from a different material with which they were in contact. Rubbing two materials together increases the contact between their surfaces, and thus the effect. For example, walking across a carpet can cause your body to accumulate static electricity. When you then touch a metal object, such as a doorknob, the excess charge is rapidly discharged, resulting in a spark. The amount of static electricity generated depends on several factors, including the materials involved, the amount of friction, and the humidity of the air. Dry air is more conducive to static electricity buildup than humid air because moisture in the air helps to dissipate the charge. The discharge of static electricity can have various effects, ranging from a mild shock to a more significant spark. In some cases, the spark can be strong enough to ignite flammable materials such as gasoline vapors or dust particles. This is why it is important to take precautions to prevent static electricity built-up in areas where flammable materials are present. Cell phones can generate static electricity through a couple of different mechanisms. Firstly, the movement of the phone within a pocket or against clothing can create friction, leading to charge separation. Secondly, the electronic components within the phone can also generate static electricity. The amount of static electricity generated by a cell phone is typically not very high, but it can be enough to ignite flammable materials under the right conditions. There have been several documented cases of fires and explosions caused by static electricity from cell phones. These incidents typically involve situations where the cell phone is used in close proximity to flammable materials, such as gasoline or propane. In one case, a man was using his cell phone at a gas station when static electricity from the phone ignited gasoline vapors, causing a fire. In another case, a woman was using her cell phone while filling a propane tank when static electricity ignited the propane, resulting in an explosion. These incidents highlight the importance of taking precautions to prevent static electricity buildup when using cell phones in areas where flammable materials are present. Preventing static electricity fires and explosions involves taking steps to minimize the buildup of static electricity and to prevent the discharge of static electricity in areas where flammable materials are present. Here are some specific precautions that can be taken. Firstly, avoid using cell phones in areas where flammable materials are present. This is the most effective way to prevent static electricity fires and explosions. If it is necessary to use a cell phone in such an area, take the following precautions. Secondly, ground yourself before using your cell phone. This can be done by touching a metal object such as a car door or a metal railing. Grounding yourself will help to dissipate any static electricity that is built up on your body. Thirdly, use a static safe case for your cell phone. These cases are made of materials that do not easily generate static electricity. Fourthly, avoid rubbing your cell phone against clothing or other materials. Rubbing can generate static electricity. Fifthly, keep your cell phone clean and free of dust and debris. Dust and debris can increase the buildup of static electricity. Sixthly, do not charge your cell phone on a flammable surface. Charging your cell phone on a flammable surface can increase the risk of a fire if static electricity is generated. Seventhly, be aware of the environmental conditions. Static electricity is more likely to build up in dry conditions. If the air is dry, take extra precautions to prevent static electricity buildup. Eighthly, use a static dissipative wrist strap when working with electronic equipment. A static dissipative wrist strap will help to prevent static electricity from building up on your body and damaging the equipment. Ninthly, use static dissipative mats in areas where electronic equipment is being used. Static dissipative mats will help to prevent static electricity from building up on the floor and damaging the equipment. Tenthly, regularly inspect and maintain your static control equipment. Static control equipment, such as wrist straps and mats, should be inspected and maintained regularly to ensure that it is working properly. Static electricity is a potential hazard that can cause fires and explosions. By taking precautions to prevent static electricity buildup and discharge, you can significantly reduce the risk of these incidents. In addition to the precautions listed above, here are some other tips for preventing static electricity fires and explosions. Firstly, educate yourself and others about the dangers of static electricity. Make sure that you and others are aware of the risks and how to prevent them. Secondly, post warning signs in areas where flammable materials are present. Warning signs can help to remind people to take precautions to prevent static electricity buildup. Thirdly, develop and implement a static control program. A static control program should include procedures for preventing static electricity buildup and discharge, as well as procedures for responding to static electricity incidents. Fourthly, regularly review and update your static control program. Your static control program should be reviewed and updated regularly to ensure that it is effective. Static electricity is a serious hazard that should not be taken lightly. By taking precautions to prevent static electricity buildup and discharge, you can help to protect yourself, your property, and others from the dangers of static electricity. Furthermore, understanding the science behind static electricity can help in implementing effective preventative measures. The amount of charge generated depends on the triboelectric properties of the materials in contact, the contact area, and the separation speed. Materials can be ranked on a triboelectric series, which indicates their tendency to gain or lose electrons. When two materials from different positions on the series come into contact, the material higher on the series tends to lose electrons and become positively charged, while the material lower on the series gains electrons and becomes negatively charged. The voltage of a static discharge can be quite high, even reaching thousands of volts. However, the current is usually very low, so the shock is not typically dangerous. The energy in a static discharge is given by the equation energy equals 1/2 times capacitance times voltage squared. Even though the capacitance is small, if the voltage is high enough, the energy can be sufficient to ignite flammable vapors. The minimum ignition energy required to ignite a flammable vapor varies depending on the substance. For example, gasoline vapors have a very low minimum ignition energy, making them particularly susceptible to ignition by static discharge. Factors such as temperature, pressure, and concentration of the flammable vapor also affect the minimum ignition energy. In industrial settings, static control measures are particularly important. These measures can include grounding equipment, using static dissipative materials, controlling humidity, and using ionization devices. Grounding provides a path for static charges to dissipate safely to the earth. Static dissipative materials allow charges to flow more slowly, reducing the risk of a sudden discharge. Controlling humidity increases the conductivity of the air, allowing charges to dissipate more easily. Ionization devices generate ions in the air, which neutralize static charges. In addition to these engineering controls, administrative controls such as training and procedures are also essential. Workers should be trained on the hazards of static electricity and the proper procedures for preventing static buildup and discharge. Procedures should be in place for handling flammable materials and for responding to static electricity incidents. Regular inspections and audits should be conducted to ensure that static control measures are being properly implemented and maintained. By implementing a comprehensive static control program, the risk of fires and explosions caused by static electricity can be significantly reduced. When dealing with electronics, electrostatic discharge or ESD is a concern. ESD can damage sensitive electronic components, leading to equipment failure. ESD damage can be either catastrophic, causing immediate failure, or latent, causing gradual degradation of performance. The precautions mentioned earlier, such as grounding, using static dissipative materials, and controlling humidity, are also effective in preventing ESD damage. In addition, workers should wear static dissipative clothing and use static dissipative tools when working with electronic components. Electronic components should be stored in static shielding bags or containers. These bags and containers are designed to protect the components from ESD damage. The effectiveness of static control measures should be regularly monitored. This can be done by measuring the static voltage on surfaces and by testing electronic components for ESD damage. If static voltages are too high or if ESD damage is detected, the static control measures should be adjusted to improve their effectiveness. Static electricity is a common phenomenon that can pose a significant hazard in certain situations. By understanding the science behind static electricity and by implementing appropriate static control measures, the risk of fires, explosions, and ESD damage can be significantly reduced. Regular training and awareness programs are essential to ensure that workers are aware of the hazards of static electricity and the proper procedures for preventing static buildup and discharge. In conclusion, while cell phones themselves may not be inherently dangerous, their potential to generate static electricity, especially in environments with flammable materials, should not be overlooked. By understanding the risks and implementing simple precautions, such as avoiding cell phone use in flammable areas and grounding oneself before use, individuals can significantly reduce the risk of static electricity-related incidents. Continuous education and adherence to safety protocols are key to preventing fires and explosions caused by static electricity.